All right. This week, I'm not gonna talk about LS-Dyna tutorial. I'm gonna call this a non-simulation related video. And what I'm gonna talk about this week is basically the creation of a Python script to divide a full input deck that's written from Workbench LS-Dyna into meaningful components. And the use of include file to link them together, right? And this is really the way os.Dyna is designed for, is to not just have a single input file, but is to have meaningful subsystems. And I want to use a script to basically be able to manipulate the input file directly without ever having to do any fancy tricks to it, right? It's basically allow me to very quickly generate the structure that I want to have in my input files. Okay, so what we're gonna talk about today is I'm gonna demo the file division very quickly, just show you how it's done, and then I'll talk about the general approach with the code, and then we're gonna look at a few key detail in the code. It's very interesting. I'm actually not gonna talk about simulations, but I feel like this is a very useful topic, and I am going to include the code in the video description. All right, to take a look at it if you're interested. All right, so let's do that. Okay, so let's see what we have here, right? What I have here is a case file. I call this case full. If you recognize, this is actually one of my input file from my previous week, in which I had basically a full input file right here. This input file is essentially is a large, is a relatively, it's a big, essentially it's a model that has both preloads and stuff in it, right? And then you can see I have all the control cards and the Mac cards and part cards and so on and so forth, and those elements in this giant file that has about 50,000 lines, right? Now, what I wanted to do is to use this quick script that I wrote to basically divide this input file into meaningful divisions, right? So what I wanted to do is to generate a control card group, a database card group, a geometry group, and a contact group, right? So all I have to do is to point the script to the location of my input file, and then point the script to the location of the directory of my output file, which is all these files that I'm writing out. And then I can just go ahead and run this script. And as you can see in this folder right here, right? So what I can sort of show you, right? So as this folder generates, let me see if I can make it cleaner. Let's do this. And then I can just link it over, and then link this over to do a nice division of my folders, right? So as soon as I run this file, right, it's going to basically generate my contact card, control card, database card, and geometry card, and it's gonna edit my original card with a bunch of include files. Now, if you look at here, right, now the nodes and elements are gone. I don't have any contact card in here. I don't have any database card. I don't have any control cards because they got separated into these subsystems. And then I can also drag and look at basically these other cards that I have, which are these individual groups that got separated out from my original file, right? And that's what I wanted to accomplish with this script. The script works as long as you can define which control card you want to, which portion of the keyword file you want to output, and what is the file name. And this is a dictionary that's the input to the main function that is going to basically do this, right? So you can add things like, for example, I can add all the part card, right? And I can say all the part .k, all the part keyword is gonna be in there. Now, of course, the part also includes section, right? I can also say the section part .k. I can also do uh, say like mat, right? And then that will just also get written out. So that's basically allows me to allow me to basically put all of these file into the parquet file if I wanted to do that. Okay, I'm gonna go ahead and delete it because I don't really want to do that. Okay, so this is the basic idea. Now let's take a look at how this is done, right? So what I did, I'm gonna put the code in the so one can just copy and use it really, but it's very, I mean, I'm gonna take the time to sort of explain a little bit of how the code is written, right? The basic strategy here is that if you look at the LS-Dyna info file, right? This is one of the most beautiful thing about Dyna is the input file, very much like I guess like an abacus. It's broken down into these keywords. Each keyword has its separate meaning, right? And you can basically change the order of these keywords that's not going to affect the input file behavior. Whereas in like APDL, right, it's a very different language. And if you change order of things, it's going to break the code. So this is very, very convenient. It's also very organized because within each keyword you have these parameter values that each of them has its meaning. So what we wanted to do, right? The basic strategy of the separation is actually really simple. I'm just gonna read the entire input file, read all 40, 50,000 lines of the input file. For each line, I'm gonna separate it into what I call blocks of lines. These blocks of lines is going to start with a star with an asterisk, ends before the next line with the asterisk, right? So these are basically the definition of your keywords. So I'm gonna break the main file into individual keyword, and based on the header of the keyword, which are these headers, right? The header here is defined as any other words before the first underscore, right? Before the first underscore, that language, that section, control, mat, that is the keyword. That's what I'm gonna define as the keyword in the code. Okay. Now with this idea, the basic approach that I'm gonna do is that I'm gonna take the input file, I'm gonna read each line of the input file. I'm gonna define my blocks of lines, right? Which is as I just described. I'm gonna define it as, find the line with the asterisk, then find the next line with the asterisk. Anywhere between them is considered a block of line, which is considered as a keyword. Now, and we're gonna use the header, which is the first line, as the header of each block of code, block of lines. The header is basically the asterisk before that, after the asterisk, before the underscore is your header. Now for each block of lines, right, I'm going to look at what the header is and write them into specific data containers, or I call them specific files. These files are basically going to be control files, database files, and so on and so forth, right? Now with each of these files, they have to basically satisfy three conditions, right? First, they have to start with keyword and ends with end, Dyna thing. Each line have to have a header that matches the file name that it gets into. So control cards goes into control files, obviously. Now for anything that doesn't match what I wanted, which are the files that should remain in the original file, I'm gonna put them into a variable called unmatched blocks. These unmatched blocks are going to be the final data container or list that I'm gonna write into a final main input file, right? And that's the basic logic of how the code is generated. Now the actual implementation of the code, I took the time to generate the flowchart before I wrote the code, because this is what I believe to be the best way to write script, is to have a very clear plan, right? So these are my data container. Each of them has a specific function, right? So I use them to store store based on a criteria that I am essentially defining, right? So for example, this is the collected block. This contains all the blocks that I'm going to be writing into files. This is the current block, which contain only the current block. This contains the unmatched block, which contains all of the keywords that do not match what I want to separate out. And the written file is a list that's going to contain all the file names, so I can add the include file into it. That's the general idea of have these four data blocks. All the data manipulation I'm doing in the code is gonna essentially either write stuff into the container, or act on the container, or take stuff out of the container. That's all it's gonna do. Okay. Okay. Now the input to the code is your directory path, your input file name, and your header that you wanted to have, which is exactly what these are, right? Which is exactly what these input parameters are. These are my input to the code. And he's gonna do basically he's gonna look at it. Does this line exist? Does this line start with an asterisk? If it does, right, it's a header. If it's a header, we have to basically treat it as a header. And if it's not a header, we'll basically just write it to the current block, right? And that's the basic idea. If it's a header, we're gonna do some actions. If it's not a header, we're just gonna write it to the current block variable, right? So in the presentation, what I did, right, is this is the basic description of the containers, right? Container 1, 2, 3, 4, each of them just basically handles specific actions. Now if I look at step 1, I have my inputs. Now step 2 here, this is a little bit busy, but this sort of captures the overall idea behind the code, right? So we're checking if the line starts with the asterisk. If it does, right? We're gonna create the header, and we're gonna reset the content of the current block to 0, right? To the null state. Basically, this essentially resets the current block to the next block of lines, right? Now, if it's not a asterisk, I'm going to put essentially that line into the current block. So in the top paragraph, right, it's going to basically, once it finds the next line with asterisks, it's going to take all the lines that I've written into the current block variable and put them into the dictionary called the basically the collected blocks. And then if it doesn't match any of the header requirements, it's gonna write it into a match blocks. And that's really what the code is doing. Is that it's gonna look at if this line starts with asterisk or not. If it does, we're gonna write all the current block into into a dictionary. If it doesn't, because if it doesn't, you're still writing lines into the current block. We're gonna keep writing lines into the current block until we finish that keyword, and then we're gonna write the next keyword, and so on and so forth. And that's the basic logic of how to separate out the files. Now, once we've separated each line, the entire input file into blocks of code or into blocks of lines, what we're gonna do is that we're gonna do a final write out, because the last line may not start with the asterisk, right? And then we're going to loop through the collected blocks and write them into files. And then we're gonna clean up the original files, which is all the unmatched keywords into a single file. That's my main file, and each of the anything that's in the collected blocks becomes a separate files. And these right here, these three bubble right here essentially represents my contact control database and geometry, right? Because that's what I wanted. This case foo right here, which has been edited, right, is going to represent basically this portion of the code, which is going to have all the include file in it. You can sort of see this original file is going to have all the include file in it, because that's what I essentially did towards the end of the script, right? And that basically completes the overall idea. Now, like I said, I'm going to put this code in the description of my YouTube video, so feel free to copy, paste, and use it. I'm going to use it almost every single day, because this has been something I wanted to do for a while now. So I've been manually cutting, pasting the input file into different files and using include manually. With this script, I can now do it basically automatically, which is going to be very, very convenient. Okay, I hope this is helpful to you. Thank you very much.